Hi guys, my name is Ivan Gutierrez Rivera and I'm here to talk you about the 6 processes to change the shape of materials. First of all, we have bending process. Bending is a manufacturing process that produces V-shape, U-shape, or channel shape along a straight axis in ductile materials, most commonly sheet metal. Commonly used equipment include box and pan brakes, brake presses, and other specialized machine presses. Typical products that are made like these are box such as electrical enclosures and rectangular duct works. And at the right, we have an image of the bending process of the machine of the sheet metal bending with a B die. The process is in press brake forming. A workpiece is positioned over the die block and the die block presses the sheet to form a shape. Usually, bending has to overcome both tensile stresses and compressive stresses. When bending is done, the residual stresses cause the material to spring back toward its original position, so the sheet must be overbent to achieve the proper bend angle. The amount of spring back is dependent on the material and the type of forming. When sheet metal is bent, it stretches in length. The bend reduction is the amount the sheet metal will stretch when bent as measured from the outside edge of the bend. The bend radius refers to the inside radius. The formed bend radius is dependent upon the dies used, the material properties, and the material thickness. The U-punch forms a U-shape with a single punch. There are 6 types. The first is air bending. This bending method forms material by pressing a punch, also called the upper or top die, into the material, forcing it into a bottom B die, which is mounted on the press. The punch forms the bend so that the distance between the punch and the side wall of the EB is greater than the material thickness. Another type is bottoming. In bottoming, the sheet is forced against the V opening in the bottom. Two U-shaped openings cannot be used. Space is left between the sheet and the bottom of the V opening. Another is coining. In coining, the top tool forces the material into the bottom die with 5 to 30 times the force of air bending, causing permanent deformation through the sheet. Another is 3-point bending. 3-point bending is a new process that uses a die with an adjustable head bottom tool moved by a servo motor. The head can be set within 0.01 mm. Adjustments between the ram and the upper tool are made using an hydraulic cushion which accommodates deviation in sheet thickness. Folding. In folding, clamping beams hold the longer side of the sheet. The beam rises and folds the sheet around a bend profile. The bent beam can move the sheet up or down, permitting the fabricating of parts with positive and negative bend angles. Whipping. In whipping, the longest end of the sheet is clamped. Then the tool moves up and down, bending the sheet around the bend profile. Though faster than folding, whipping is a higher risk of producing stretch or otherwise damage the sheet because the tool is moving over the sheet surface. Collapsing cross section to example of bending process. Microbending is simple stated to bend in a small curvature. Bending in a small curvature might result in a collapsed cross-section. We control the collapsing cross-section to improve the exterior to as high a level as possible to become available for products, like the image that you see at the right. Another process is hydroforming process. Hydroforming was developed in the late 1940s and early 1950s to provide a cost-effective means to produce relatively small quantities of draw parts or parts with asymmetrical or irregular contours that do not lend themselves to stamping. Virtually all metals capable of cold forming can be hydroformed, including aluminum, brass, carbon, and stainless steel, copper, and high-strength alloys. The step 1 of this process is hydroforming press operates like the upper or femoral die element. This consists of a pressurized forming chamber of oil, a rubber diaphragm, and a wear pad. The lower or male die element is replaced by a punch and ring. The punch is attached to a hydraulic piston and the blank holder or ring which surrounds the punch. The step 2 is the hydroforming process begins by placing a metal blank on the ring. The press is closed, bringing the chamber of oil down on top of the blank. The forming chamber is pressurized with oil while the punch is raised through the ring and into the forming chamber. Since the femoral portion of this forming method is rubber, the blank is formed without the stretches associated with stamping. The step 3 is the diaphragm supports the entire surface of the blank. It forms the blank around the rising punch, and the blank takes on the shape of the punch. When the hydroforming cycle is complete, the pressure is forming chamber is released and the punch is retracted from the finished part. And the step 4 is, as you can see in the image, the finished part. It is top of press raised, pressure released, and punch lowered. The part is now finished. Hydroforming process example. In 2002, Dodge began incorporating hydroforming to help reduce chassis vibration on its redesigned Dodge Ram. Likewise, General Motors suppliers began using hydroforming to create the suspension parts. There was an eventual increase of approximately 20% in manufacturing productivity for General Motors, and the switch to hydroforming might have contributed to the gain. Another process is forge process. Forging is a manufacturing process involving the shaping of metal using localized compressive forces. The blows are delivered with a hammer, often a power hammer or a die. Forging is often classified according to the temperature at which it is performed. Cold forging, a type of cold working, warm forging, or hot forging, a type of hot working. For the latter two, the metal is heated, usually in a forge. Forge part can range in weight from less than a kilogram to hundreds of metric tons. Advantages and disadvantages. Forging can produce a piece that is stronger than an equivalent cast or machined part. As the metal is shaped during the forging process, its internal grain texture deforms to follow the general shape of the part. As a result, the texture variation is continuous throughout the part, giving rise to a piece with improved strength characteristics. Additionally, forgings can target a lower total cost when compared to a casting or fabrication, considering all the costs that are involved in a product's life cycle from procurement to lead time to rework and forging process example: automobile industry, wheel spindles, kingpins, axle beams and shaft, torsion bars, bolt studs, either arms and stern arms. Agro industries, engine and transmission components, levers, gear, shaft and spindles to tie roundels. Aerospace, bulkheads, hanks, wing roots, engine mounts, breakers, beams, shaft, landing gear, cylinders and throws. Extrusion process. Extrusion is a process used to create objects of a fixed cross-sectional profile. A material is pushed through a die of the desired cross-section. The two main advantages of this process over other manufacturing processes are its ability to create very complex cross-sections and to work materials that are varied. The process begins by heating the stock material for hot or warm extrusion. It is then loaded in the container in the press. A dummy block is placed behind it where the ram then presses on the material to push it out of the die. Afterward, the extrusion is stretched in order to strike it. If better properties are required, then it might be heat treated or cold work. Extrusion example. Examples of the metal that can be extruded are copper, lead, tin, aluminum, alloys, titanium, molybdenum, vanadium, steel, which are used to make parts like collapsed tubes, gear blanks, aluminum cans, cylinders, etc. In automobile sector, they have found wide application in injection technology, engine control, fuel supply, automatic transmission seat technology, safety system, restraint system. Punching process. Punching is a forming process that uses a punch press to force a tool, called a punch, through the workpiece to create a hole via churing. Punching is applicable to a wide variety of materials that come in sheet form, including sheet metal, paper, vulcanized fiber, and some forms of plastic sheet. The punch often passes through the work into a die. Process. Punch tooling punch and die is often made of hardened steel or tungsten carbide. A die is located on the opposite side of the workpiece and supports the material around the perimeter of the hole and helps to localize the jarring force for a cleaner edge. Punching process example. Punching is often the cheapest method for creating holes in sheet materials in medium to high production volumes. When a specially shaped punch is used to create multiple usable parts from a sheet of material, the process is known as planking. Stamping process. Stamping, also known as pressing, is the process of placing flat sheet metal in either blank or cold form into a stamping press where a tool and die surface form the metal into a net shape. Stamping process example. Metal stamping can be applied to a variety of materials based on the unique metal working qualities for a number of applications across a wide range of industries. Thanks for watching this video. I hope you enjoyed this video, and I hope that you found this video interesting and very useful for your